Good morning, students. Now I will discuss with you this theorem on tau, two theorems on sigma n and tau of n. So first of all, let us see the first theorem, theorem 1. It states that if n is equal to p1 to the power e1, p2, that is a product of r distinct primes, where p1, p2, pr are distinct primes, then show that the number of divisors of n of this form is equal to product of ei plus 1. So here what we do is, you are given Pn is a product of r distinct primes p1 to the power e1, p2 to the power e2 dash dash pr to the power er. So this implies that where pi's are distinct primes. So this implies that tau of n here will be equal to tau of, you replace n by this, that is p1 to the power e1 into p2 to the power e2 dash dash into pr to the power er. And we know that tau is a multiplicative function. Tau, that is tau of mn is equal to tau of m into tau of n whenever GCD of m and n is equal to 1. So here, since p1, p2, they are all distinct primes, they are relatively prime in pairs. GCD of p1, p2, or we can say in general, this GCD of pi and pj is equal to 1 with I different from j. So this implies that tau of this is same as tau of p1 to the power e1 into tau of p2 to the power e2 dash dash tau of pr to the power er. Now what we are going to find, what is the formula for this? As we know here, now tau of pi to the power ei in general, where I varies from 1 to r, this is equal to, what are the divisors of pi to the power ei? They are 1 pi square dash dash pi to the power ei. So these are all divisors of how many terms are there? From here to here there are ei terms plus 1. So therefore tau of pi to the power ei is nothing but that the number of divisors of pi. So you have ei plus 1. So therefore tau of n here equal, that is this one, which is equal to, you replace I by 1, so you'll get e1 plus 1 into e2 plus 1 dash dash into er plus 1, and which is nothing but product of ei plus 1, where I varies from 1 to r. So this complete the proof. Similarly with sigma also, by sigma we stands for the sum of the divisors of n. So here this is sigma of p1 to the power e1, p2 to the power e2 dash dash pr to the power er. And since pi's are distinct primes, so therefore, and sigma is a multiplicative function, I have proved this, that is sigma of m into sigma of n whenever GCD of m and n is equal to 1. So you replace this by using this result here. So pi's are distinct primes, so we have tau of p1 to the power e1 into tau of p2 to the power e2, because sigma is a multiplicative function, dash dash sigma of pr to the power er. And what are the divisors of pi to the power er here? pr to the power pi to the power ei, they are 1 pi square dash dash pi to the power ei. So, but what is meant by sigma? Sigma stands for the sum of the divisors of pi to the power ei. So therefore, now you name this as equation 1. Now let us find what is sigma, not tau, sigma of pi to the power ei, where these are all the divisors of pi to the power ei. So it is the sum of this according to definition of sigma, 1 plus pi square plus dash dash plus pi to the power ei. And this is equal, there is a formula for this, it is pi to the power ei plus 1 minus 1 divided by pi minus 1. But I here varies from 1 to r, so this implies that sigma of n, which is equal to sigma of p1 to the power e1, it is nothing but p1 to the power e1 plus 1 minus 1 divided by p1 minus 1 into sigma of p2, it is p2 to the power e2 plus 1 minus 1 divided by p2 minus 1, and so on, dash dash sigma of pr to the power er, it is PR to the power ER plus 1 minus 1 divided by PR minus 1. So this whole thing can be written in the form of product PI to the power EI plus 1 minus 1 divided by PI minus 1, where I varies from 1 to R. So this complete the theorem, that is, if n is equal to P1 to the power E1, P2 to the power E2, that is a product of R distinct prime powers, then sigma n is equal to product of Pi to the power Ei plus 1 minus 1 divided by Pi minus 1. I hope it is clear to you. Okay, so let's stop here.